All right. So, good afternoon, good day, everyone. Welcome to our new discussion for this afternoon. Okay, this afternoon we are going to tackle about naming compounds. Okay, which involves the aqueous acids and oxyacids. Okay, but before that, I would like to request, okay, for my students to please comment your section, okay, your course, okay, and don't forget to include your section and your complete name for you to confirm your attendance in our class for this afternoon. Again, please comment your course and your section, okay, in order to confirm your attendance of our discussion this afternoon. Okay. However, if you might face some technicalities, okay, basig hinay yung signal or na may problem about our live, don't worry because you can replay our discussion right after we have our live discussion about our topic this afternoon. Okay, so I think most of your classmates are here already. So let's start. So, before we'll proceed with our new topic, okay, let's have to recap first about the things that we tackled last week. Okay, so on on our previous videos, okay, online, okay, we tackled about the chemical formulas. Okay, and we learned from that discussion that chemical formula is it gives us, okay, a notation of the ratio of the number and type of atoms present in a molecule. Okay, it allows us to understand, okay, the number of atoms present in a molecule, and it's very important for us, okay, in order to know as well the properties and characteristics of the compounds that we are referring to. So this time, we are to tackle about how to give names to the compounds that has hydrogen, okay, because most of the compounds that contains this element class is being referred to different types. Okay, it has categorization. Okay, natay gitawag og aqueous and oxyacids. And those were the things that we are going to tackle this afternoon. So understanding the naming conventions of binary hydrogen compounds and their transformation in aqueous acid is crucial in chemistry for several reasons. First, it helps in accurately identifying and distinguishing compounds based on their chemical behavior. For instance, we have hydrogen chloride. Okay, the hydrogen chloride in its pure element, okay, in its pure form, I mean, is a simple binary compound. Okay, however, when we dissolve this compound in water, kung ato ni siyang i-dissolve sa water, it will become an acid. And its name will change to hydrochloric acid. However, when we try to look at its symbol, its chemical formula, they actually look the same. Okay, you can have HCl. However, for acid, it's you can see parenthesis aqueous. Okay, so that's just the difference of the two. Okay, it behaves when it is an acid form. Okay, it behaves as a strong acid, which is significant implication of chemical reaction. So what's the significant of this class? Unsa may gamit niya anhi? What's the implication of this? Why do we need to know how to call a compound? Okay? We need to identify, okay, the name of compound according to its symbol. It's because for us to um, know, okay, kung unsay atong gamit anha nga compound. Kay lahi ang gamit sa acid ug sa simple binary compound. Kung mabaylo na nimo sila, let's say for example, you conduct an experiment and then mabaylo ng duha, well of course you can have different outcome sa imuhang gi-experiment. Okay, this naming system also reflects the compound's properties in aqueous environments, which is particularly important in biological, environmental, and industrial contexts where acid plays a vital role. Okay, in biological system, acids are involved in cellular respiration, digestion, and pH regulations. Industrially, acids like hydrochloric acids are essential in the processes such as metal refining, chemical synthesis, and wastewater treatment. Okay. Additionally, recognizing these naming conventions is fundamental for you students. Okay, because it introduces you to acid-based chemistry and prepares you for more complex topics in chemistry, just like pH calculation, okay, acid strength and reaction mechanisms. Okay, those were just some of the difficult topics in chemistry that you might face, okay, which is very hard if you don't know the basics. Okay, you don't if you don't know the basic of um, okay, naming compounds, well, of course, you cannot understand the terms that you might encounter in higher topics in chemistry. All right, so let's proceed. Let's start with okay, naming binary compound which is composed of hydrogen. Okay, again, naming binary compound which is composed of hydrogen. A binary compound which is composed of hydrogen and more electronegative element is named just like the other binary compound. So we are done discussing this last week on how to name binary compound. Okay, for this, if it contains hydrogen, all you have to do, the same thing with what we did with our previous discussion, you just state the first element, hydrogen, okay, that will be your first word, and the second word is made by affixing IED to the root word of the non-metal. Okay, again, you start with stating the hydrogen because hydrogen is your first word. Okay, and then after that, you um, the second word is made by adding IDE, okay, which is your uh, suffix, okay, of the root word of the non-metal that you use. Let's have this one. Our example for this is we have HCl. Okay, the symbol HCl. Okay, this is the chemical formula, the HCl, and we name it as hydrogen chloride. Okay, we just read the H as hydrogen and Cl as chloride. Okay, Cl here stands for the element nonmetal chlorine, which has high electronegativity. So mo na nga gikuha na to ang root word ni chlorine and then we just add the uh, suffix IDE, which gives us the name hydrogen chloride. Okay, the same principle applies to the rest of the compound, okay, when hydrogen is being paired with other nonmetals. Okay, so hydrogen iodide, okay, hydrogen oxide. Okay, so inga na ara siya. That's very simple. So this time, okay, when this binary compounds, okay, is being dissolved in water, okay, it will become an aqueous acids. So those binary compounds that contains hydrogen and other nonmetals, if being immersed in water or dissolved in water, it will become an aqueous acid. Okay, so an aqueous acid is an acid dissolved in water. Okay, it is used in chemistry to refer to anything dissolved in water. So na sagol naman siya sa water, that's why it's called aqueous acids. So to name aqueous acids, okay, so we use the prefix hydro, okay, which is being attached to the root word of the non-metal, and suffix IC is written. Okay, the word acid becomes the last word. Again, the prefix hydro is attached to the root word stem of the non-metal, and suffix IC is written. The word acid becomes the last word. Okay, that's just very simple. Let's have an example. We have here HI, okay, which is aqueous. So to name that, we use the prefix hydro, and since I is an the I symbol is an iodine element, so atong buhaton uh, we just get the root word, I mean the stem of the element iodine, and then replace it with the suffix ic, and then add the word acid at the last part. So we name it hydroiodic acid. Okay, the same thing with the rest. Okay, so kung wala, if you won't see that parenthesis nga na AQ, okay, the AQ there stands for aqueous. Kung dili na nimo makitaan nga symbol, you just name it the same, uh, with the same principle as we name binary compounds. Okay, pero kung naa na gani na parenthesis AQ, that means it's an aqueous acids. That's why you need to use the prefix hydro and IC, okay, to name it, okay, as an aqueous acid. Again, HI here becomes hydroiodic acid, and HCl becomes hydrochloric acid. So unsa may iyahang name if this is not aqueous? Okay, how do we name this if it's not aqueous? Kung binary siya, if this is binary compound that is composed of hydrogen, how do we name this? Okay, the first example, this one is hydrogen iodide. Again, hydrogen iodide. And the second one is hydrogen chloride. Okay, however, aqueous naman siya, that's why it becomes hydroiodic acid. And the other one becomes hydrochloric acid. Okay, all right. Always remember that they have the same components, hydrogen and iodine. Okay, for the other one. Yang isa, hydrogen and chlorine. Okay, nautro lang ang iyahang property. It's because of the external factor. Okay, in this case, water. So let's proceed. So, okay. So when, okay, okay, kung kadto nga compound is being natay gipuno nga oxygen, okay, it will now be called oxyacids. Okay, it will be called oxyacids or ternary acids. Ternary acids or oxyacids are acids that contain oxygen. Okay. Oh, well, of course, it must have the element hydrogen. Dili mawala si hydrogen when we say acid. That's why hydrogen plus oxygen and any element. Okay. Again, for oxyacid, you must have hydrogen, oxygen, and any element. So katong duha may dili pwede nga mawala. So how do we name oxyacids? Well, there's a thing that you need to remember. If the last three word of an oxyanion, okay, of an anion nga naay oxygen is um, ITE, okay, your your suffix to be used in naming the acid is OUS. Okay, unsa to? Kung ITE ang last kani ITE, kay imuhang suffix sa inigname nimo sa oxyacid is OUS. However, kung ATE, AT and E ang last three letters sa imuhang oxy and ion, you must replace the suffix, okay, into IC. Okay, so let's have an example. Okay, we have here for permanganate. So permanganate. So if we will name it as an oxyacid, okay, punan na ni nato og H or hydrogen, it will become, okay, permanganic acid. Okay, it will become permanganic acid. Okay, so did you observe what changes do we have here? Okay, we just omit ATE and replace it with IC. Okay, and then add the word acid. Okay, so inga na ra. How about this one, carbonate? Okay, what's our answer? How do we name it in acid? It will become carbonic acid. Okay, this one, nitrite. Okay, it ends with ITE. It's called, okay, very good. It's called nitrous acid. Okay, this one, ATE. Okay, ATE. It becomes nitric acid. Sulfite become sulfurous acid. Sulfate, sulfuric acid. Perchlorate, perchloric acid. And phosphate, it becomes phosphoric acid. So very basic. All you have to do is remember that if the last three letters or the suffix of the oxy ion is ITE, okay, you must replace it with the suffix OUS and add the word acid. If the last three word of an ion is ATE, okay, you must replace it with the suffix IC and add the word acid. It's very basic, and I hope that you understand on how to name oxyacids. Um, and we have aqueous acids and also those binary compounds that contains hydrogen. Okay, so if you have any concern and question about our discussion this afternoon, okay, you are free to comment in the comment section. Okay, and for my students, I'd like you to answer these exercises. Okay, you answer these exercises in one half crosswise yellow paper, and we'll check your answers during our face-to-face classes. Okay, so no more concern about our discussion this afternoon. Okay, if none,